I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about binary codes and classification of binary code. Later on, we will study about binary codes in depth. But in this video lecture, just introduce our binary codes and we'll see our classification of binary code. So let us define what exactly we mean by binary code. Now we know that we have all the data that is known as digital data. So digital data is represented, digital data is stored, and if it is transmitted as groups of binary digits, also known as binary code. This is known as binary code. We do the encoding and at the end, after receiving the data, we do the decoding. Sometimes we store data and all this group of binary digits that is known as a binary code. And to know the exact value or the exact what it represents, then we should know that which type of binary code we have used. So let us see the classification of binary code. We have different types of binary codes. So let us see classification. We have binary codes. Then we have weighted binary code. Then second, we have non-weighted binary code. Then we have a reflective code. Again, we have sequential code. Then alphanumerical code. And at last, we have error detecting and correcting code. We have sub-classification of this main binary code. On the screen we can see that we have total 6 different types of binary code, but again we have sub-classification of all the binary codes. So we start with the weighted binary code, then we have straight binary code as well as BCD code. BCD, that is binary coded decimal value. If we go for non-weighted binary code, then we have access3 code as well as we have gray code. In case of reflective code, we have 2421 code, 5211 code, or access3 code. Access3 code is non-weighted as well as it is reflective. If we go for sequential code, then we have 8421, that is BCD code. BCD code is weighted code, but at the same time it is sequential code also. Then we have access3 code. Access3, you can see that it is non-weighted, reflective and sequential as well. Then alphanumerical. We have ASCII code, ASCII ASCII code, as well as we have EBC DIC code. Then at last we have error detecting and correcting code, and then we have parity code as well as we have Hamming code. So this way we have a classification of our binary codes. Now we'll see each code in brief. Now let us start with weighted binary code. We know that what exactly we mean by weighted binary code. In weighted codes, each digit is assigned a specific weight according to its position. So far we have discussed our straight binary code, and we know that each digit, each bit has its own value based on the position, and that is known as a weighted binary code. So our binary codes, straight binary codes, 2421, 5421, 7211, These all are known as a binary code. At the same time, we have BCD code, and that is known as 8421. So these are weighted binary code, and all the bit has its own value according to its position. So this is known as a weighted binary code. At the same time, we have non-weighted binary code. The non-weighted codes are not positionally weighted. As per the position, there is no any specific value, right? So we have XS3 code or gray code, that is an example for non-weighted binary code. Then we have a reflective code. A code is reflective when the code is self-complementing. Suppose code 9 is one's complement of code 0. Same way, code 8 is one's complement of code 1. So it is self-complementing. And XS3 code or 2421 or 5211 are known as a reflective code. Then we have sequential code. In sequential code, each succeeding code is one binary number greater than its preceding code. So it is one binary number greater than its preceding code, and then it is known as sequential code. 8421, that is BCD code, is sequential code. XS3 also is known as sequential code. Then we have alphanumerical code. Codes used to represent numbers, alphabetic characters, symbols, and various instructions are known as alphanumerical code. We have ASCII code, ASCII, and that is known as a American Standard Code for Information Interchange. And then we have EBC DIC code, and that is known as Extended Binary Coded Decimal Interchange Code. So these two examples are for alphanumerical type of code. Then we have error detection and correcting code. Sometimes we transmit our digital data from one place to another place, and during transit there may be a possibility there is an error, right? So at the end we should have different code to identify or to detect the error, as well as we can able to correct the error. So codes which allow error detection and correction are called error detecting and correcting code. An example for error detection, that is parity code, and for correcting code we have Hamming code. So these are some of the classification of codes, but as per our syllabus we will not be studying all the codes together, but we will focus on BCD code, XS3 code, and error detecting code, that is parity code. In parity code we have odd and even parity generator and parity code. So we will study these three binary code in our next lectures. So thank you for watching my video. Keep watching. Thank you very much.